understanding that what is our next point which we are going to study. So this is going to help you to grasp what I am teaching in this particular lecture. So we will continue with the high pressure measurement. Now, yesterday also I have told you that one of the concept that you can use the primary transducer and secondary transducer. Why we are using primary? Because primary transducers are generating the analog output. However, for the process instrumentation or any control system components, we are interested to have the resultant output with reference to that of potentiometer measurement in terms of electrical one. So the output generated is, though it is in the form of analog one, but the resultant output generated will be in terms of electrical one. And the advantage of the electrical output is the accurate resultant output generated is much more less one is analog one is the less accurate compared to that of electrical one. So we will take the reference of elastic type of pressure measuring devices or elastic type of pressure measuring instrument. So what are the elastic type of pressure measuring devices that we have studied was a diaphragm type, bellow type, then Borden tube type, and this elastic type of sensor or this elastic type of transducer that has been used for the pressure measurement. Somewhat when we are using the dial gauge, at that time the observation error may be there. So this observation error or this noting error may be avoided or may be uh, overcome utilizing some electrical type of transducer incorporating in connection with a analog type of transducer, that is bellows, diaphragm, or your Borden tube. So the input pressure which we are going to provide, that input pressure will try to generate the resultant output in analog for the primary transducer, and that analog output is converted to the digital one depending upon the deformation that has been carried out based on applied pressure as an input that has been given to the electric one. So the constructional detail of this one is very simple. In the next slide, I have enlarged this figure along with some content. So it consists of spring, bellow, one hinge is there, and potentiometer is there. One of the cantilever beam is also provided, and at one of the end, we people, bellow is also similar to that of a spring, and at the upper end, we are also having a spring. So the middle stem, which is associated across the potentiometer, it will hold the condition. So when it is having the equal strength applied from the spring side and from the pressure side. But however, when the unknown pressure is applied to the bellow, these bellows are going to be elongated one, and there will be a movement of pointer. In the upcoming slide, I will show that particular aspect. So here we are using the elastic pressure measuring device, which is linked to the wiper or which is linked to the potentiometer. So over here, actually, what we people are going to visualize is measurement of this one, measurement of uh, potential difference when pressure is applied. So diaphragm deforms, it moves the wiper on the resistive element. It changes the resistance of the wiper, which turn changes the output voltage. So output voltage is proportional to the applied pressure. Output voltage is proportional to the applied pressure. Now, how this one works is shown in this particular slide. Whatever I have specified in the previous one, this is the connecting rod or pointer also we people can say. So this rod is actually linked between your bellows and the spring, between your bellows and the spring. So what happened, this spring is having some tension, and bellows, as we have seen, this is elastic type, so it can be elongated one, it can be compressed one, it can be elongated one, or it can be compressed one. So when we are applying a pressure, at that time these bellows are going to be elongated one. So as this spring is connected or linked with the stem, what is going to happen? This bellows will push this spring in the upward direction. When this spring is pushed in the upward direction, this connecting rod with a pointer, as it is connected over here, as this one is connected at this particular place, this pointer will try to move in the either upward side or the downward side. And we are well aware with the concept of the potentiometer, that when this connecting rod is moving across the potentiometer or rheostat, its resistance is going to vary. Now, when the resistance is going to vary, the resultant output generated will also vary. That will also vary. So, this variation is totally depend upon the pressure that has been applied as an input to the bellows. Okay. So, your voltage, output voltage, it may increase or it may decrease, because as per the Ohm's law, V is equal to IR. Now, what is going to change? The resistance is going to change, which is going to reflect on change in the voltage, which is going to reflect on the change in the voltage. But what causes to change in voltage? Actually, the change in voltage is caused due to change in resistance, and this change in resistance is due to the movement of the pointer, but the movement of pointer is linked due to the depend upon the input pressure. If you increase this unknown pressure as an input, there will be large elongation across the bellows, or deformation will be much more greater. As the deformation increases, this will try to shift in the upward direction. When this is moving in the upward direction, it is going to exert the pressure on the spring, so pointer will move in the upward direction. As you reduce the pressure, the elongation or deformation will reduce, and this spring will provide the strength to move towards the downward direction. So this spring will try to move in the downward direction along with the connecting rod varying this particular resistance. So the output generated is nothing but it is the effect of the change in the resistance caused due to the applied pressure causes variation in the voltage. So my voltage is calibrated in terms of pressure, because the input pressure causes the variation in the voltage, but this variation in the voltage is due to the variation in the resistance across the connecting rod that has been arise due to the connecting rod. So this is one of the example. And here, if I specify which one, the output is analog. If you see over here, what is the output of this one? This output is analog. Analog in terms of motion, over here. But the output generated at potentiometer is electrical one. So which one is my primary transducer? This bellow is my primary transducer. Whereas this potentiometer, I will represent it with a red color. This potentiometer is my secondary transducer, secondary transducer. Okay, so for better resolution or accuracy, we people are trying to convert this analog output into electrical one. That's why the two transducers are used for the measurement of pressure, in which One is acting as a primary transducer and another one is acting as a secondary transducer to get the better resultant output. So this is one of the example uh, that can be fruitfully incorporated or designed or developed for the measurement of pressure. Either you can use over here, you can use uh, Borden tube, you can use diaphragm, you can use bellow. So bellow's example I have shown for you people. The another diaphragm example in the previous lecture we have seen. So with this particular system, actually what are the merits and demerits of this one? By utilizing the analog one or elastic type one and then your non-elastic or electrical type one also. So there are some advantages as we know that some systems are having similar to that of a human good things and bad things. So good things are also there in the system and some bad things are also in the system, which is reflected in terms of advantages and disadvantages. So what are the advantages or merits? It is having the higher resolution. This is much more robust. Robust means a rigid one. And this the constructional detail of this particular system is a simple one and proper, efficient, strong output we people are getting from this one. And also the significant thing for this one, there is no need to design any signal conditioning device to amplify that particular signal. As we people will see in temperature measurement thermocouple, the resultant output of thermocouple is in terms of millivolt, which is not of use. For that one, we have to amplify that particular one. So here in the previous system, whatever we have studied primary and secondary, there is no need to amplify the signal. So designing cost of that one complexity also has been reduced. But along with this one, there are some limitations also. So finite resolution is there for this particular system. Then limited life, that is a lifespan for this one for the larger size, because here wear and tear may take place if you are using a rheostat or any connecting type of device. At that time there may be a wear and tear, and after wear and tear there may be a loss of signal also, or error may be generated one. Other than that, the frequency response generated using this particular system is a poor one, along with the noise. Noise may be generated in all the mechanical system, because this is also one type of mechanical system, and in mechanical system it is habitual that the generation of noise can be present, or generation of noise will take place. Sustainability to the vibrations. Actually, what happens, spring we have used, and we have seen some of the accelerometers. So damping action may take place. So as there is a spring, and if we try to mount it in a noisy environment or vibrating environment, where in the mechanical system, at that time this vibration may lead for the movement of the spring, and due to the movement of spring the connecting rod will move, that will change the resistance, causing the voltage change. So false output may be generated. So we have to take the care this system or such a type of